So, AI is everywhere, right? It's in our phones, it's driving our cars, it's doing just about everything. But have you ever stopped and wondered what it actually takes to build it? Not the buzzwords, but the real down-in-the-trenches skills? Okay, let's decode this.
So what are the real ingredients for building artificial intelligence? To figure that out, we did something a little unconventional. We actually got our hands on a real university syllabus for a degree in AI and machine learning. And we're going to use it as our map, our blueprint, to see what it really takes to engineer the future.
All right, so here's the first thing you notice, and maybe the first surprise. The most fundamental pillar of AI isn't some fancy code or a robot brain. It's data, just massive amounts of it. Before you can teach a machine to think, you've got to give it something to think about.
And that whole process of getting the data ready, it doesn't even start with the fun part, the analysis. It starts with this absolutely crucial foundational step called ETL. This is the behind-the-scenes work that makes everything else even possible.
ETL stands for extract, transform, and load. And the best way to think about it is like you're trying to organize a gigantic, messy, global library. First, you extract. You go out and gather every book from every corner of the world. Then, you transform them. You translate them into one common language, you fix all the torn pages, you organize them by subject. And finally, you load them onto the shelves, perfectly cataloged and ready for anyone to read. Without that, you don't have a library, you just have a useless pile of paper.
And this is where it gets really interesting, because the curriculum makes it clear that AI needs a totally different kind of library. A normal database, that's like a cash register. It's just handling today's transactions, what's happening right now. But a data warehouse, that's built for analysis. It holds historical data. All the information from last year, 5 years ago, all aggregated and structured specifically to find patterns. This is the key. The entire foundation of AI is built on this special analytical library of information.
Okay, so the library is built. The data is clean, organized, and ready to go. What's next? Well, now you have to teach the machine how to learn from it. And that brings us to the machine learning course in our syllabus. This is where the magic really starts to happen.
In machine learning, you find there are two main ways a machine learns. The syllabus calls them supervised and unsupervised learning. Supervised learning is kind of like studying for a test with the answer key right in front of you. You show the AI thousands of emails that you've already labeled spam or not spam, and it learns to predict which is which. Unsupervised learning, on the other hand, that's like being thrown into a messy room and just being told to find groups. The AI gets a ton of unlabeled data, say customer purchase histories, and its job is to discover its own patterns, like creating different customer groups you never even knew existed.
And to do all of that, students have to master a whole toolkit of algorithms. You can think of these as the power tools of machine learning. Now, you're seeing some of their technical names here, things like k-nearest neighbor or support vector machines. You don't need to memorize them. The big idea is that each one is a specialized tool, a unique way of slicing through data to solve a very particular kind of problem. It's all about having the right tool for the right job.
But of course, we don't stop there. From here, the curriculum moves to the real frontier of AI. This is where we get into the seriously advanced stuff, with courses like reinforcement learning and deep learning, and pattern recognition and computer vision. This is where AI starts to feel like something straight out of science fiction.
One of the absolute coolest concepts here has to be reinforcement learning. With this, the AI learns through pure trial and error. Forget labeled data, it's exactly like training a puppy. When it does the right thing, you give it a treat. The AI agent works the same way. It tries an action, and if that gets it closer to its goal, it gets a virtual reward, which reinforces that good behavior. This is literally how an AI learns to master a complex game or control a robot arm.
And this isn't just theory, not by a long shot. The curriculum shows that students are actually in the lab building these systems from scratch. They're engineering the brains behind a game-playing AI, they're building chatbots, they're creating models that can analyze movie reviews for sentiment or recognize objects in an image. They're using advanced tools like CNNs, a type of neural network for vision, to turn these abstract concepts into real, working products.
So at this point, our student is a technical powerhouse. They can wrangle data,
build learning models, and operate on the frontiers of AI. The journey has to be complete, right? Well, the syllabus has a surprise. There's one more crucial and completely unexpected part of the puzzle.
Because you can build the most brilliant AI in the world, a true work of genius. But if it just sits on a server and nobody ever uses it, what's the point? Which leads to this pivotal question. Is technical skill, on its own, really enough to change the world? And the answer, according to this degree, is a clear no. Because tucked right alongside deep learning and data mining is this surprising course, Principles of Entrepreneurship Mindset. Yep, after all that hardcore tech, students learn how to think like a founder. And it tells us that building the AI is only half the battle.
And the syllabus for this course? It reads like a startup playbook. It's not about code, it's about developing a business idea, building a competitive advantage, creating a financial plan, marketing your product, and leading a team. You could have the best sentiment analysis model ever created, but you need these skills to turn it into a successful company that actually helps people.
So now we can see the full picture. The goal isn't just to create a coder or a data scientist. The goal is to create something much more holistic. So let's put these two halves together. This is the final profile, the complete AI engineer. This person doesn't just understand deep learning. They know how to assess a market opportunity for it. They don't just know data mining. They know how to build a competitive advantage from that data. They can fuse technical mastery like pattern recognition with practical needs like financial planning. This is the ultimate goal, a rare and powerful combination of deep technical skill and sharp business strategy.
So, in the end, this AI degree isn't just about building algorithms. It's about building solutions, products, and even entire companies. It's a blueprint for turning raw code into real-world impact. Which leaves just one final question for you. Now that you know what it takes, what problem would you solve?